Exponential functions. I gotta tell you, I really, really like this material a lot. And not so much the stuff we begin with, but the stuff we end with. I like that a lot. And the reason why is because it's technically just using Algebra 2 skills in a way we didn't know we could. I love when I'm shown that something I know how to use can be used in a new way. I just love that. I love it. So this kind of math, lots of fun for me. Exponential equation is an equation in which the variable occurs as part of the exponent. Okay, we know that. If the base of the numbers are the same, then we can equate the exponents. What? Huh? All right, basically, if you have exponential thing equals exponential thing, your goal is make the bases equal. Because if the bases are equal, the only way it's a true statement is if the exponents are equal. So the basic setup is get the bases to be equal to each other, and then you can forget about them and just say the exponents are equal, and you can solve. That's the basic strategy. So remember, the exponential bases must match. So for part A, we have 2 to the x equals 16. Now, I don't just want to say the answer. I want to demonstrate a skill. I need to make both sides have the same exponential base. Luckily, 16 is a base 2 number. 16 is 2 to the 4th. And now that the bases are equal to each other, the only way that this is a true statement is if the exponents are equal to each other, and oh look, we're done. That's it. Not a very good example. I don't like it. The next one's a little bit better. First things first, what bothers you? It's a fraction, right? Okay. Well, why don't we just write it as not a fraction? So what would make it not a fraction? Right. Yeah, well, not make the number negative, but the exponent. But yeah, if we said that this was some number with a negative exponent, then it wouldn't have to be a fraction. And this is a little more work than I would ask that you do in the future, but for now we're just demonstrating that I could have written this as 27 to the negative 1. Good. We are on our way. Let me tell you what you're never allowed to do. You are never allowed to divide by an exponential base. Don't do it. What you are allowed to do is hope or force the exponential bases to be the same. Luckily, 27 is a base 3 number. 27 is 3 to the 3. Now, in the future, I would hope that you go directly from 1 over 27 straight to 3 to the negative 3. If you can't go straight to it, that's fine. You're welcome to go through the step of raised to the negative 1. It's fine. There's nothing wrong with that. And now that the exponential bases match, the only way it's a true statement is if the exponents are the same as well. So x plus 2 must be equal to negative 3. And we just subtract 2 from both sides. And that is how you're going to get that x equals negative 5. Another reason why I love this material so much is it goes so well with the way that I teach logarithms, which, by the way, are the next unit after this one. Oh, the symbol that I created, you just can't use it. You can't use my symbol, even though my symbol for logarithms works in my mind, is so much easier to understand than the word log. It's such an abstract thing. You'll see. Okay. Some guy I can call. Hey, Captain Math, can we please switch logs to my symbol, please, please, please? Mm-hmm. So, all right, guys, this one. This one's. I don't want to use the word trick question, but it's kind of tricky because at least Algebra 2 students look at this and go, oh, true, exponential base 4. Yeah. No. You see, 8 is not a base 4 number. 8's divisible by 4, but it is not a power of 4. But 8 is a power of 2. And so is 4. So what we can do for part A is we can reduce down both sides to base 2 numbers. So instead of saying 4 to the x, I could say 2 to the 2x equals 2 to the third. I skipped over a step right here. I skipped over a step of work. Oh, snatched my microphone off my shirt. Put that back on. Anyway, I skipped over a step of work. I don't know if you guys need to see it. So tell you what I'll do. I'll just go ahead and include it just in case. Boop. Grabbed it. Oh, man. That's not going to let me do it. I tried to get fancy. I skipped over a step right here. Like that. And of course, when you raise a power to a power, you multiply. I don't know if it was necessary to show it. Well, now that the exponential bases are equal, the only way it's true is if the exponents themselves are also equal. So 2x equals 3 and divide by 2. You get x equals 3 over 2. I'd rather have a fraction than a decimal. 1.5 is the same answer though, but I like that one better. That's not bad, right? Yeah, the pitfall is if a student says that 8 is 4 to the 2, which is what you see a lot. I'm pretty sure that question is on my Algebra 2 test for exponentials. Because it's not hard if you know what you're doing. But it does check whether or not you know what you're doing, I guess. Part B. What exponential base do these two sides share? 3. Yeah, they could both be written as base 3 numbers. So for 9 raised to the x minus 2, instead I'm going to say it's 3 squared raised to the x minus 2. And on the right side, 1/3 is 3 to the negative 1. And you must remember to distribute this exponent. 3 to the 2x minus 4 equals 3 to the negative 1. And it's an equation. The only way it's true is if both sides are equal to each other, right? Well, the bases already match. So it can only be true if the exponents match. 2x minus 4 equals negative 1. We'll just go ahead and add 4 to both sides. It gives me 2x equals 3, and then divide both sides by 2, and you get x equals 3 over 2 again. So solving this kind of exponential function by hand, or exponential equation, excuse me, by hand, not very hard, is it? Not scary. I am going to hit you with some food for thought, though. And if you know the answer, don't say it. I'm just going to hit you with some food for thought. Normally, when we go from one step in the work to the next, we get to the next step using some kind of algebra, correct? Added to both sides or divided both sides by 2, things like that. What kind of algebra is, since the bases match, we won't worry about them? What kind of algebra is that? That's not math. And yet we were doing it. I wonder what allows us mathematically to do that. Anyway, moving on. It's food for thought. Not yet, I'm not. Not yet, I'm not. It's food for thought. See, right here. Every time I move from one step to another in a solving process, there's clearly some algebra happening at each level, right? But what algebra happened from here to here? What algebraic process made it so that I could just disregard the exponential basis? That's not algebra, is it? Yeah, it seems pretty simple, but that's not math, that's common sense.
Why is it not algebra?
Because algebra are mathematical operations. That's not an operation, though. Every time I move from one level to the next, I use an algebraic operation, except for when I said, okay, since the bases match, let's just disregard them. That is not an algebraic operation. But I will tell you, there is an algebraic operation that allows me to do that. We just haven't talked about it yet. So we'll go ahead and move on. This is the only thing on the back, right? Okay. I absolutely love this kind of question. You know why? Well, yes, I like math. But the reason why I absolutely love this is because it's a quadratic. And we are going to solve this quadratic by factoring. And when I said that, Savannah's face crunched up, because it doesn't look like a quadratic, does it?
No, but
Sure doesn't. Ah, but you've noticed that 4 is 2 squared. Right. So tell you what we're going to do. I'm going to write this as 2 to the, oh goodness, that's red. 2 to the 2x plus 2 to the x minus 20. And just to manipulate it a little bit more so it looks more like a quadratic, I realize that right here there's a multiplication of exponents, and that only happens when there's a power raised to a power, so I could have written it like this. And if you're still not seeing a quadratic, you could use this method of substitution. Now you don't have to, and it wouldn't ever get you any marks, but you could do this. You could say, let me redefine my variables. Let me let m for Mathman McCutcheon equal 2 to the x. Because if I do that, what this actually says is m squared plus m minus 20 equals 0. And that is a quadratic that we can easily solve by factoring. Be looking for the two numbers that multiply to negative 20 that add to positive 1. Well, those would be 5 and negative 4. So m plus 5 times m minus 4 equals 0. If we were solving for m, isn't it true that m would have to equal negative 5 and m would have to equal positive 4? Is this true? Yes, it is. But we were not solving for m. We were solving for x. M is 2 to the x. I think it's really, really obvious what the answer is on the right side. 2 to some power equals 4. 7 in it? No, not 7. Right here, I think it's pretty obvious that x equals 2. But let's look at the, and if you weren't sure how we did it, you could. It's 2 to the x, and 4 could have been written as 2 to the 2. Since the bases match, make the exponents match. There it is. But on the left side, positive 2 raised to a power equals negative 5. Thoughts? Anybody? So what we've done in the past is in the previous examples, we tried to make the bases equal. Well, I can tell you that 5, no matter what you do, is not ever going to be base 2, at least without the use of logarithms. So we're not going to do that. I think we're all missing something incredibly obvious here. The number positive 2 raised to powers equals a negative number. Illegal. This is completely impossible. It is not possible to raise a positive number to a power and get a negative result. Completely impossible. So the answer is x equals 2. Hold on. Wait, Savannah?
Well, for these equations, will we always have one answer, or are there times where we'll have two?
There are times where you could have 2 answers. Yeah. Yeah. I mean, I could design one really quickly that does have 2 answers. The dead giveaway to me that this one had 1 answer was the fact that the polynomial ended with a negative number. Because that means when I factored it, I had to have 1 positive solution and 1 negative solution, and the exponential will never be negative. However, if the last number is positive and the middle number is negative, there would be 2 solutions. And if the last number is positive and the middle number is positive, there are no solutions. But you don't need to know why I know that. You just need to know that, make sure they're possible. That's all you have to do. Factor and solve for x. And that's it.
So when people solve it, you just kind of give one variable that replace situation.
I'm sorry?
Whenever solving one of these, you can just replace that.
Now, if you can factor it without replacing the variable, if you can see it, then go for it. I replaced the variable because I think it makes it more obvious that yes, this thing can be solved the same way a quadratic can be solved. Yeah, but IB doesn't ever give marks for that kind of thing. So
if you're trying to get method marks in
general, so here's where the method mark would come from. That's a really good question. Luca wants to know where the method mark would come from in a question like this, because substitution will never count as a method mark. Hey, I'm trying to help you guys earn points up here. Method mark. The method mark would come from the attempt to solve. Student used a viable method to attempt to solve, and the viable method would have either been the quadratic formula or factoring. So the moment you got down to any type of factored thing, you would have earned a method mark. Even though you reassigned the variable, it doesn't matter. Student tried to factor. So that's where the method mark would come from. Now, I told you in the past, if you mess up the method in the beginning, you can't earn any marks after that. Well, that's not quite true. You could still earn method marks. So if you mess up the method at the beginning, you can't earn any accuracy marks, but you can still earn method marks. So if it's a more complex question than this one, and there would have been more than one layer of it that required method, you could still earn more method marks. But yeah, the method would have come from attempting to substitute. That's where it would have come from. And that is it.